In this tutorial will be shown how you can reproduce an example from the book of Joop Hox of 2009 using the LME4 web application. I happen to have a copy here of chapter 2 of the book, and in this video we will reproduce the basic two-level regression model. I also have the data on my desktop, so let's begin. We start by opening the web application. And I like to use the application in full screen mode because it gives me more space to model. So I press F11 to start full screen mode. Well, let's upload the data, which is here. Well, we start by selecting the dependent variable, which is popularity. And now we have to define which variable is the grouping variable. So that's class in our case. So we right click this variable in the menu. And then we select new random effects group. So this creates the intercept only model. Well, if we have fitted this model, let's see how this compares to the intercept only model from the book. So that is this table. We can see there's a very small difference in deviance between the model that was estimated in the book and that was estimated by our application. The reason for this is that the book apparently used maximum likelihood estimation, while the application by default uses restricted maximum likelihood for Gaussian distributions. So if we want to reproduce the model from the book, we have to set this to false and refit the model. Okay, so this model is the intercept only model. That's exactly the same as in the book. The deviance is 6327. Which is the same as here, and the estimates are also the same. And by the way, if you want to calculate the residual variance, that's the square of the sigma that's reported here. Right, so let's add model M1. So we click add model to start a new model, and again we select the class as the grouping variable. We start adding the predictors. So gender, extroversion, teach experience, and random slopes for extroversion and gender. Well, let's try and fit this model. Alright, so let's see how this compares to the book. The deviance is estimated as 4812 in the book. And it's practically the same here. There's a very small difference. The fixed effects are also practically the same. And the random coefficients are also similar. There's only a small difference between the random intercept, which is estimated as 1.28 in the book, and our application estimates it at 1.30. Not sure what happened here, but I think the reason is that the software that was used in the book did not succeed in estimating the variance for the gender random slope, while we did. So that might make the difference, or it's simply due to rounding or convergence or something like that. Anyway, it's not going to matter because in the next model we will remove this random slope. So again we start a new model. And we repeat the steps that we did before. Add the fixed effects. And add the random effect for extroversion. So let's fit this model. Now this should be the same as the model from table 2.2. The deviance is estimated at 4812.8, which is correct. And also the estimates are the same as reported in the book. You can verify that yourself. By the way, the covariance between the random intercept and random slope can be found under the covariance matrix. So pressing this opens a window and you can see that the covariance between the random intercept and random extroversion slope is estimated at minus 0.18, which is this value. Now if we would like to compare this model to the previous model, so the model that had the random slope for gender, so this model, and we want to compare it to our new model, we can press the ANOVA button, and that gives us an analysis of variance table. Please caution, because the order of the models has been changed to ascending degrees of freedom. So this is our latest model, model 3, and this is model 2. You can see the difference is 3 degrees of freedom, which is the variance and covariances of the random slope for gender, and we can see that the difference is not significant if you if you're into significance testing. So we can safely say that we can remove the random slope for gender. Alright, well, let's see what happens next in the book. Now we will add a cross-level interaction for teacher experience and extraversion. So we create a new model, and again repeat the steps as before. So we add gender, extraversion, teacher experience, and we add the random slope for extraversion. But we also want the cross-level interaction. Now within the LME4 package there's no real difference between a regular interaction and a cross-level interaction. So we can simply select extraversion and teacher experience. If you hold down the control button, you can select multiple variables from the menu, right click and add the interaction effect. So that adds the interaction effect. If we press fit model, that should give us model M2. So let's verify that. The deviance is 4747, which is correct, and also the estimates are correct. Well, again, if you would like to see if the difference between these models is significant, then we can press the ANOVA. We want to compare model 3 and model 4, so we have to look at this row, and we can see that the difference between these two models is one parameter. So that's the fixed effect for the interaction, and that parameter is very significant apparently. There's a huge difference between the deviances, so we can say that it was a valuable addition to the model. Alright, if you want to do something similar as was done here in MLWin, it's here called an error bar plot of the level 2 residuals, and you can do something similar by pressing the dot plots. This shows you an estimate for every class on the random intercept and extraversion, and you can see the estimated standard error. So for example, we can see that for this class the estimated intercept is outside the confidence intervals for almost all of the other classes. So this really is a substantial variance for this parameter. Now the final thing we would like to do is we would like to save our analysis. So we can press the analysis report button, and this generates a PDF report of all models, so we can save it to our computer and discuss it with colleagues. So this shows the ANOVA table and a summary for all models and some plots. Well, just have a look at it. Well, that was it. Thank you for watching.